A local arena has 10 applicants interested in working at the snack bar. How many ways can 4 applicants be chosen? So first of all, you look at this question and say, is this decisions that I need to do spaces, or is this a combinations? Does the order matter? If you hired the same 4 people in a different order, is that different? No. So we go, okay, here the order doesn't matter. That means it is a combinations question. I have 10 people, I need to choose how many? 4 of them. So the answer to A is just 10, choose 4. And the answer to B is if all of a sudden you're like, oh, we actually need 6 people, would be 10, choose 6. And the interesting thing about this question is when you actually put it into your formula. So remember, the formula is going to have the 10 factorial on the top, the 4 factorial on the bottom, and then the other number has to add up to the top number. So it's going to be 4 and 6. And the second one is 10 factorial with the 6 factorial on the bottom, and the second one has to add up to the top. And all of a sudden, you realize that these are identical. And it actually makes sense. And I'll show you this with cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I take 10 cards, and these 10 cards represent the 10 resumes that the applicants put forward, every time I choose a group of 4, I'm left with a group of 6. 4 people are working, 6 people didn't get the job. Does it make sense that when I make a group of 4 where the order doesn't matter, I'm left with a group of 6 where the order doesn't matter? So choosing a group of 4 from 10 is identical to choosing a group of 6 from 10. Does that make sense? So you're going to get questions that are going to look like this. 12, choose x minus 2. Okay? 12, choose x minus 2 is the same as 12, choose x. What's x? And if you go to the formulas, this becomes very complicated to look at and solve. But if you know how combinations work, if this is true, these two numbers, every time I make a group of 4, it's the same as a group of 6. They have to add up to 10. So now, this question is really asking this. What does x have to be so that x minus 2 plus x has to equal 12? Well, I can combine my like terms, move the 2 over to the other side. And 12, choose 7, or this side would be 5, equals 12, choose 7. Yes, if I have 12 things and I make a group of 5, I'm left with a group of 7. So there are things in this connection and combinations is important. And sometimes it's going to be much easier to figure out the other one. For example, here I take a whole deck of cards, 52 cards. Okay? I want you to count how many different hands are possible where the order doesn't matter, where you get 51 cards. So for example, this is one example. And this is another example of 51 cards that you could have chosen. And it's hard for our brain to hold those in our head because there's so many cards. But 52 choose 51. Every time I choose 51, I'm left with 1. Right? And if I asked you, there's 52 cards, you get to choose 1. How many different ways could you do that? 52 ways. Our brain is able to do that easily. But 52 choosing groups of 51 where the order doesn't matter. You're like trying to hold all 51 cards in my head saying, okay, I've counted this one. What haven't I counted yet? Is much harder. So that is an important concept that comes up here in example 2. And you can circle questions 8 and 10.